Okay, assume A, B, C are all real numbers. If A, B equals B, C, then A equals C. Is this statement true or false? Well, at first glance, it seems that you can cancel a B to both sides, so that gives us A equals C, right? But is that always true? For example, we know 2 times 0 equals 0 times 3, right? Because both of the left side and the right side is 0. But in this case, this is our A, this is B, this is B, this is C, right? So in this case, we have A times B equals B times C. Does that indicate A equals C? Well, in this case, A is 2, C is 3. A is not necessarily equal to C, right? So this is not necessarily true. Not necessarily true. Can you see that? It is true only if and only if B is not 0. We can have AB equals BC indicates A equals C. Can you see that? Because we can divide both sides using the non-zero number B. So AB equals BC will give us A equals C. And this is only true when B is not 0. Okay? So it's not necessarily true if B belongs to the real number set. If there is no constraints, this statement is not necessarily true. Can you follow me? Okay, then number 2, assuming A, B, C are all real numbers, if A equals B, then A raised to the power C equals B raised to the power C. Is this statement true or false? Again, same thing. You need to consider some corner case. For example, we know if A equals B equals 0, then C equals 0, we don't have 0 to the power of 0. This is not defined, right? So again, we can find a counterexample. So again, this is not necessarily true. Because when all of these numbers are 0, the left side is not defined, the right side is not defined, so you cannot compare which is larger, right? Can you follow me? Okay, you need to consider corner case. Alright, then next question. Evaluate or simplify the following expression. Okay, again, this first expression involves the exponents, right? So basically we have 27 is 3 to the power of 3, right? 27 to the power of 3 means 3 to the power of 3, then to the power of 3. Then divided by 9 to the power of 2 is actually 3 to the power of 2, then to the power of 2, right? Then times 3 to the power of 5. You follow me? And each of these expressions can be expressed as 3 raised to some powers. So the numerator is 3 to the power of, okay, Sandy, can you tell me this number here? What should I put here?
9.
Yeah, 9 is correct, because we can use the first property here, right? So that equals 3 to the power of 9 divided by 3 to the power of 4 times 3 to the power of 5, right? And according to the property number 7, well, first of all, this equals 9 to the power of 9. Again, you can use property number 1 to calculate the denominator, right? 3 to the power of 4 times 3 to the power of 5 equals 3 to the power of 4 plus 5, which is 9, right? And then 3 to the power of 9 over 3 to the power of 9. Of course, this equals 3 to the power of 9 minus 9, which is 0. And this will give you number 1, right? You see that? Okay, how about second one? Okay, second one, square root 15 times square root of 5 equals square root of 15 times 5. Can you see why? Because square root of 15 times square root of 5 is actually, well, square root of 15 is 15 to the power of 1 over 2, right? Times 5, square root of 5 is actually 5 to the power of 1 over 2, right? And according to the property number 3, we know we can calculate the product first. That equals 15 times 5, then together raise to the power of 1 over 2. And again, 5 times 15 to the power of 1 over 2 is actually the square root of 15 times 5. You see that? So next time when you see if you have the same nth root of some numbers, you can put them together under the square root symbol, right? So 15, square root of 15 times square root of 5 is actually square root of the product of these two numbers. And then minus square root of 27 minus square root of 12, right? And this equals, okay, first of all, square root of 15 minus 5 times 5 is 5 times 5 times 3, right? Minus 27 is 3 squared times 3. Square root 12 is actually 2 squared times 3, right? So again, the first one is actually 5 squared times 3. So if you have 5 squared times 3, then find its square root. That actually equals square root of 5 squared times square root of 3, right? We can detach these two numbers. Can you see that? And again, the square root of 5 to the power of 2, this is actually 5 to the power of 2, then to the power of 1 over 2. Then 2 times 1 over 2 is actually 5 to the power of 1, right? So that gives you 5. Can you see that? Therefore, when you want to find the nth square root of a number raised to the power of n, that actually equals a, right? So this will give you 5 times square root of 3, which is 5 square root of 3. So that equals 5 square root of 3. And follows the same rule. What is the second expression? Can you tell me? Sunny? What is the result of square root of 3 squared times another 3?
27.
Yes, of course, it's square root 27, right? So can you put some numbers in front of the square root symbol? So can you write it like 3 times square root 3? Do you know how to do that?
Yeah.
Okay, so that equals 3 times square root 3, right? Usually, we'll simplify that as much as possible. Therefore, we can combine the like terms. So how about the third one? Can you simplify this? Sunny? Okay, I'll write one more step for you. So if you have a product two numbers under square root symbol, that equals square root of the first number times the square root of the second number, right?
Yeah.
What is square root of 2 to the power of 2?
Square root of 4.
What is square root of 4? Okay, I'll give you another hint. Square root of some number is actually this number raised to the power of 1 over 2, right?
Yeah.
So 2 to the power of 2, then to the power of 1 over 2. What is this number here? Can you simplify that? As 2 times 1 over 2, right? You follow me?
Yeah.
So that equals 2 to the power of 1, right?
Yeah.
And next time, you can just directly write square root of 2 to the power of 2 is actually 2. So that's 2 times square root of 3, right?
Yeah.
Okay, so let's erase all of it. And next time, when you calculate or simplify such expression, you should immediately know that's actually, you can put the 2 in front, right? So that'll give you 2 times square root 3. Then you will have 5 square root 3 minus 3 square root 3 minus another 2 square root 3. So what is the final result? Honey? Can you hear me? Yeah, that is correct. Very good. Yeah, Sunny, can you tell me the final result?
Yeah. 0, I think.
Yeah, 0, because square root 3 is a common factor. We can put it in front, and you will have 5 minus 3 minus 2, right? And that'll give you 0. Very good. Okay, next one. Again, try to simplify these two numbers under square root symbol. So can you find any perfect square number here? So first one will give you 98 is actually 49 times 2, right? Times 5 times 18 is actually 9 by 2, right? So can you simplify that? Okay, again. Okay, how about Jackal? Simplify the first one.
21 times the square root of 2.
Yeah, we can put a 7 in front, right?
Yes.
Okay, how about Sunny? Can you simplify the second one? Okay, I'll give a hint. 9 is actually 3 to the power of 2, right? Then if you have any number squared under square root symbol, you can just put that number in front, right? Outside of square root symbol. So what is the simplified form of second expression?
5 times 3 times the square root of 2.
Yes, that's correct. Thank you. And then you will have, remember, we can change the orders of the numbers when you have a product of several numbers, right? So we can calculate these numbers. That's 21 by 15. Then you will have square root 2 times square root 2 is actually square root 2 then squared, which gives you 2, right? Can you follow me? So the final result is 27 by 30, which gives us 630, right? You follow me? Any questions? All right, next one. So which property we can use to solve the next one? We have the first number raised to the power of 1 over 2, and the second number raised to the power of 1 over 2. So we can use this property, number 8, right? Can you see that? Therefore, that should equals, we can find the fraction first, then together raised to the power of 1 over 2, right? Together raised to the power of 1 over 2 is actually the square root of 75 over 27, right? You follow me? Sunny?
Yeah.
Okay.
Yes.
So next time, okay, very good. So next time when you see a expression like this, you can directly write this is actually square root of the fraction of these two numbers, right? The reason I just show you, right? So that equals square root of, let's find some common factors so we can cancel that. 75 can be divided by 3. So we'll have 25 times 3. This equals 75, right? 27 is 3 by 9. Then we can cancel the 3 here, right? Which gives us square root of 25 over 9. So can you find the result? Give me a final result in the chat box, okay? Ben, Jacob, Sunny, what is the square root of 25 over 9? Okay, received Ben's answer, Jacob's answer. How about Sunny? Sunny? Can you hear me? Yes, 5 over 3 is correct. Because this basically is square root 25 over square root 9 over, right? Square root 25 is square root 5 square. Square root 9 is square root of 3 squared, right? Remember, when you have a square root of something squared, that equals this number, right? And denominator is 3, so that'll give us 5 over 3. Of course, you can just leave 5 over 3 there. You don't have to write it 1 and 2/3, okay? Of course, if you write 1 and 2/3, that's also correct. But usually you can just leave it there. 5 over 3 is enough. Okay, then let's have a look at the next one. Okay, next one, when you have a square root of a decimal number, usually we'll convert this number to fractions because at first glance, it's not very easy to find the square root of a decimal number, right? Unless you use a calculator. So this time we can convert it to a fraction first. 92 over 92.16 is actually 9216 over 10,000, right? So the advantage of doing this is we know 10,000 is actually 10 to the power of 4, right? Then immediately you should know 10 to the power of 4. If it's under a square root symbol, you can actually put it outside the square root symbol, right? If you put it outside, that's actually 1 over 10 to the power of 2. Can you see that? Okay, and the key is to see whether the numerator is also a perfect number or can be written as a product containing a perfect square number. Okay, 92 over 9216. So apparently that can be divided by number 4, right? If you divide that number by number 4, you will get okay, so 4 by 2304, right? And then check whether this number can be further divided by 4. Okay, then again that equals 4 by 4 by 576. If you can't still see how to factor this number, so try another 4, right? Okay, and we have 9216 equals 1, 2, 3, 3/4 times this number here, right? And we do know 144 is actually 12 squared, right? So continue factoring that number until you see some patterns which is easily to recognize. You know 144 is 12 by 12, right? So that means the numerator can be written as 4 by 4 by 4 is actually 2 by 2 by 2 squared, right? You see that? And that's actually 8 squared times 12 squared. So this will give you square root of 96 squared and then 10 squared and then squared, right? And remember, if you have something squared under square root symbol, we can put it in front. So that equals 96 over 10 to the power of 2, which equals 0.96. Did you get it? Any questions? And the takeaway here is when you see a square root symbol of a decimal number, next time you can convert that to a fraction and then find the perfect square numbers inside that number. Okay? Yes?
So like question E is like 92.16. So don't we just need like
oh, sorry. I made a mistake, right? This should be sorry.
Yeah, 100.
Yes, this should be 100, right?
Yeah.
Sorry about that. That should be 2, not 10,000. My bad. So that should be 10, and you will get a 10 here, right? So final answer is 9.6, right? Okay, Sunny, can you follow me here?
Yeah.
Okay. All right, I'll just erase all of this. Then you should do this on a scratch paper, okay? Here I only keep the final result with some steps in between. Okay, how about the next one? 27 raised to the power of -2 over 3. Okay, first of all, when a number raised to the power of a negative power, then we know that's 1 over 27 to the power of 2 over 3, right? This is according to the property number 5, right? And then let's find what is 27 to the power of 2 thirds. So that equals 1 over 27 is actually 3 to the power of 3, right? Then to the power of 2 thirds. So that equals 1 over 3 to the power of 3 times 2 thirds. Then we can cancel a 3 here. That gives you 1 over 3 to the power of 2, which is 1 over 9, right? Can you follow me?
Yes.
Okay, good. How about Sunny? Or the other student? Do you understand? Okay, any thoughts of question G? Well, it seems that we might have a large number, right? But note that this number can be written as 1728 times 1000, then to the power of 2 thirds, right? You see that? And this will give you 1728 to the power of 1/3 times 1000 times to the power of 2 thirds, right? And let's observe this number here. So can you factorize that such that this number is some number raised to the power of 3 or something. Apparently, this number can be divided by number 2 and 3, right? So it can be divided by 6. So let's have a look at, if we divide that number by 6, what we'll get. So we can put a 2 here, 8 here, another 8 here, right? Okay, so we know that number is 6 by 288. And 288 can also be divisible by 6. So that is 6 times 4, 8, right? And 48 can still be factored to 6 by 8, right? So we know that 1728 is actually 6 to the power of 3 times, note that 8 is also 2 to the power of 3, right? And then together to the power of 2 over 3 times 1000 is 10 to the power of 3, then to the power of 2 over 3, right? And this will give you, first of all, it's 6 to the power of 3, then to the power of 2 thirds, times 2 to the power of 3 times to the power of 2 thirds, times 10 to the power of 3, then to the power of 2 thirds. Then that equals 6 to the power of 3 times 2 over 3. This can be cancelled. So that'll give you 6 to the power of 2 times 2 to the power of 2 times 10 to the power of 2, right? So that'll be 36 times 4 times 100, which is 14400, right? Can you follow me? Sunny, can you follow me?
Yeah.
Alright, so any thoughts for the next one? This one is similar to the question in E, right? Again, we can convert the decimal number to a fraction. So that's negative 216 over 1000. This is cubic root of negative 216 is actually 6 to the power of 3, right? And 1000 is 10 to the power of 3. And immediately we should know that's actually negative 6 over 10. Can you see that? Sunny? Can you follow me on this? Okay. Okay, then let's take a 5 minutes break, okay? Please return before 3 past 10, okay?
Okay.
Alright, welcome back. Let's continue our discussion on the homework. Jacob, Sunny, are you here?
Yeah.
Alright.
Yes, I'm here.
Okay, next one. What is the smallest positive integer n such that square root of 315 times n is an integer? So for this number to be an integer, we need this number to be inside the square root symbol to be a perfect square, right? So first of all, let's have a look at how we can factor 315 such that if you add another factor n, this number is a perfect square. So 315, apparently this number ends with 5, so it's divisible by 5. So let's use a 5 to test this number first. You can put a 6, then you can put a 3 here, right? So 315 is actually 5 by 63, and we know that'll give us 5 by 63 is 7 by 9, right? 9 is already a perfect square, but 5 and 7 are not. So in order for 315 to be a perfect number, we need to come up with a perfect number. When you add n here, so can you guess what is n such that this number is a perfect square number? Sunny, any ideas? Sunny, can you hear me?
Yeah.
So what can n be such that this number is a perfect square number? A perfect square number is some, for example, 5 square is a perfect number, right? 7 square is another perfect square, so then the product of these two numbers is also perfect square, right? And times 3 square is also perfect square number. So can you guess what n should be such that this number can be a perfect square number?
Can I answer that?
Yes, please.
Oh, it's 35.
Yeah, so n should be, we should add a 5, right? Add a 7 as well. So that equals 35. Because you need to have 2 5s, 2 7s, and 2 3s in order for this number to be perfect square, right? Can you follow me? Sunny?
Yeah.
Okay, then next question. For what value of n is the following equation true? Okay, so first of all, let's try to simplify this equation, okay? So the left side is already in its simplest form, which is 2 to the power of n. We can't do anything about it. The right side, first of all, we have 4 to the power of 1/3, right? So cubic, remember that cubic root is actually 4 to the power of 1/3, right? And then square root is actually 32 to the power of 1/2, right? Can you follow me? And we also know 4 is 2 to the power of 2. And 32 is actually 2 to the power of 5, right? Then to the power of 1/2. Then we can combine the right side to 2 to the power of 2/3 times 2 to the power of 5/2, right? So that equals 2 to the power of 2/3 plus 5/2. So can you find the sum of these two fractions? We can rewrite this using a common denominator 6, right? So note that 2 over 3 plus 5 over 2 is actually, the common denominator is 6, right? So 2 over 3 is actually 4 over 6 plus 5 over 2 is actually 15 over 6. So that'll give you 19 over 6, right? So basically you have 2 to the power of n. 2 to the power of n equals 2 to the power of 19 over 6. Of course, we know n must equal 19 over 6, such that the left side can equal the right side, right? Can you follow me? Alright, then Sunny, can you follow me? Okay, then let's consider the next one. Simplify or evaluate each of the following expressions. Again, this checks your understanding of the properties of exponents. So the first one equals. Well, let's simplify the coefficients first. So basically, you have a negative 8. 8 can be cancelled with 4, leaves you a 2 here, right? 2 can be cancelled with 6, leaves you a 3 here, right? So first of all, we will have a 2 over 3. That's the coefficients. Then we'll consider the terms that involves u, right? So basically, you have u to the power of 4 over u to the power of 2 times u to the power of 3, then u to the power of 3, right? So these two can be cancelled with each other. That leaves us 2 over 3 times u to the power of 4 minus 2 is 2, right? And of course, there is a negative symbol in front. Do not forget the negative symbol, right? So we should put a negative symbol in front of that. So that gives us negative 2 over 3 u squared. Can you follow me? Alright, then question B. Okay, first of all, we can factorize both the numerator and denominator. Note that for the numerator, we can put the cube in front, right? Of course, you can also put 15 in front. Then what's left in the parentheses is z plus, z squared plus z plus 1, right? Can you follow me? Sunny, can you follow me?
Yeah.
And can you do the same thing for the denominator? Can you also factorize that? So what should you write it in the factored form, Sunny? Jacob?
Excuse me? Yeah.
Yeah, you can answer.
The denominator will be 12z times z the third power, or second the two power of the
Square.
z squared plus z. Yeah.
Plus 1,
And
right?
1. Oh yeah.
Yes. Then we will have the identical terms here. So these two terms can cancel with each other, right? And 15 cancels with 12. This leaves us, because we have a common denominator, 3, right? So we can divide both this number with 3. That leaves us 5 over 4, right? So that equals 5 over 4. Z cubed over z gives us z squared, right? So the final result is 5 over 4 z squared. You follow me? Okay. And next one, factor the following expressions. Okay, first of all, we can put a common greatest factor in front. First, let's check these numbers. 42 is 6 by 7, right? 36 is 6 by 6. 92 is 8 by 9. And 8 by 9 is actually 6 by 12, right? So all of these numbers have a common factor 6, so we can put a 6 in front, right? And then consider the u here. We can put a u in front as well. So if you put 6u in front, so what's left in the parentheses? Sunny, can you tell me that? Sunny, can you hear me? Yeah, according to the distributive laws, if I put a 6u in front, what expression is left in the parentheses? Sunny, can you hear me? Then, any ideas?
7u squared plus 6u minus 12.
Yeah, it should be 7u squared plus 6u minus 12, right? Okay, and if you're not confident with the result here, always use a distributive law to put it back to see if you can have the original expression, right? So if you assign 6u back into the parentheses, you will get 42u cubed plus 32u squared minus 70u, right? And apparently this is identical with the original. So your factoring here is correct. So actually we can further factorize the expression here, but currently let's just leave it here because we haven't learned the method, okay? If you know the method, you can further factorize that, but currently it's okay to leave it here. We'll talk about that in the future chapters, okay? It's okay to leave it like this. We'll talk about other factoring method later, okay? And next one, how to factorize this. Okay, note that there is a common factor for 8 and 56 here. We can put 8 in front, then what's left in the parentheses is just r minus 7, right? So r minus 7 is a common factor. We can then put it in front, then what's left there is 2r plus 8, right? Then 2r plus 8 has a common factor 2. We can put 2 in front, so that leaves us 2 times r minus 7, then times r plus 4. You follow me? Sunny, can you follow me?
Yeah.
Okay, then let's consider. Okay, have a look at this question first, and I'll give you 1 minute to have a look at these factoring questions, and then we'll have a look at the next one, okay? Alright, if you don't have any questions, let's have a look at question number 8. This is another type of question. It asks us to write this sum as a single fraction. Remember, if you want to write a sum of several expressions as a single fraction, you need to find the least common multiple of all the denominators, right? Least common multiple of all denominators. So in this case, it's okay. The first one, the denominator of the first one is just 1, right? So basically, we need to find the least common factor of 2z minus 1, z, and 2z squared minus z. Note that 2z squared minus z can be expressed as z times 2z minus 1, right? So the least common factor of all least common multiple of all denominators is just 2z minus 1 times another z, right? That's enough. So we can express that to 2 times 2z minus 1 times z over 2z minus 1 times z, right? If you cancel this, you will get the first number 2, right? That's the first term, plus the second term is 4. We can multiply that using a z here, then 2z minus 1 times z, right? And if you cancel a z here, you will get 4 over 2z minus 1 as the second term, right? And for the third term, we need to multiply a 2z minus 1 to both the numerator and denominator. Again, if you cancel this, you will get 3 over z, which is the third term here, right? You follow me? And the last one is we don't need to do anything about it because it already have 2z minus 1 times z, right? Then we can combine all the terms here. You will have 2z times 2z minus 1 plus 4z minus 3 times 2z minus 1 plus z. And the denominator is the common denominator now, which is 2z minus 1 times z, right? And then next you need to expand the numerator, right? I'll write it here. The numerator is 4z squared minus 2z plus 4z minus 6z plus 3 plus another z, right? If you combine all the like terms, you will get 4z squared minus 2z plus 4z minus 6z plus z will give you minus 3z, right? And then we'll have a plus 3. That's the numerator. So eventually we will have a result like this that equals 4z squared minus 3z plus 3 over 2z minus 1 times another z, right? Can you follow me? That's the final result. So as long as you can rewrite this as a single fraction, you should be fine. Any questions? Sunny, do you have any questions? Jacob, Ben? Okay, Ben's fine. Jacob's good. How about Sunny? Okay, then next one. Again, rewrite this using a common denominator. Okay, first one, you need to find that common denominator, right? So in this case, what is the least common multiple of this and this and this? So note that 2 is just 2 over 1, right? 3 over z and z minus 2 over z minus 1. You need to find a least common multiple of these 3 terms. In this case, that's just the 1 times z minus 1, which is z times z minus 1, right? So we know that that equals, well, first of all, 2 is actually 2 times z minus 1 over z times z minus 1, right? And of course, if you cancel these two terms, you will get first number 2. Second term is 3 over z, which means 3 times z minus 1 over z times z minus 1, right? Again, if you cancel z minus 1, you will get 3 over z, which is the second term. For the third term, we can multiply both the numerator and denominator using z, right? And then if you cancel the z, you will get a third term, z minus 2 over z minus 1, right? You see that? So in this way, we have successfully rewritten all of the terms using the common denominator, z times z minus 1. Can you see that? Okay, Jacob's fine, Ben is fine. How about Sunny? Can you follow me?
Yeah.
Okay, then we can rewrite all of the terms. The numerator is just z times z minus 1, right? Then for the numerator, you will get 2z times z minus 1 plus 3z minus 1 minus z times z minus 2, right? And then you can expand the numerator. Well, let's just keep the denominator unchanged. Expand the numerator will give you 2z squared minus 2z plus 3z minus 3 minus z squared plus 2z, right? Be careful when you have a negative symbol in front. When you expand it, you need to change this symbol from negative to positive, okay? Be careful with that when you have a negative symbol in front. Do you understand? So if you combine all the like terms, you will get only 1z squared and minus 2z. Okay, you can combine this term with this one and combine negative 2z plus 3z will give you positive 1z plus 2z will give you positive z, right? So we have a positive 3z, right? And then negative 3. So that's the numerator, right? Divided by z times z minus 1. So that is our final result.